All right, so let's get started. Thank you very much for coming to this presentation and choosing our session. This session is titled Unlocking New Platform Experiences with Open Interfaces. We will be talking about different tools here with Thomas. And I think that we can get started because we only have 30 minutes.
Yes, let's get started.
Yep.
So we want to go through the journey that usually developer teams go through. There are some challenges. In particular, when we have a new business idea, we want a development team to take on a new task, build a new application, and we have this onboarding process that, depending on the technology we are using or the infrastructure we are relying on, might be quite challenging. How do we bootstrap a new project? How do we establish a local development workflow? It can be really challenging, especially when working with distributed systems where we have to integrate multiple applications with multiple data services. Some of them might run locally, but how about cloud services? We have some challenges there.
We do.
And then once we are done with the development part, we have to deliver the application. We have to publish it in production. That's where it delivers its value. So we have some further challenges in terms of how do we maintain that application at runtime and how do we operate the underlying platform.
That's correct.
And that's what we're going to look at today.
Yeah, definitely. And in order to do that, what we built, this is a small demo. It's just 4 services. The application is written here in this diagram. It's just showing Java. But actually, we have different services written in different languages. And as you can see, it's not just the application. It's also the application infrastructure. So like databases or key value stores and message brokers and configuration servers, secret stores, and all these kind of things. We copied the idea from a Docker sample application that it's basically something that we will be using now with you folks. So if you help us, I think that we can run kind of like the demo now.
Yeah, let's have a look. And also, we would like you to play with us. So let's first show the QR code.
So we have the QR code. Can you scan that? And let's see if we can all interact with the application. So that's the URL on top. Or if you scan that QR code, you should be able to access the app.
Yeah, let's switch to the application. And we'll keep also the QR code on screen. If you haven't scanned it yet,
we can see some bots coming in.
And we have this long-time debate, Mauricio and I, about cats and dogs. I'm more of a cat person. Mauricio is more of a dog person. So let's see who's going to win this time.
Then you say 52%. Let's do it. And you can see that you can keep changing your vote. I think that's pretty cool. So this is pretty much the application is composed by 4 different services, as I mentioned. The first one is where you're interacting with. You're voting, casting a vote. That vote goes to Redis. There is a job worker that is basically doing some translation between the data that it's in Redis into an SQL view, into Postgres. And that's what the result service, the middle screen, is picking up there and refreshing every 2 seconds, I think.
Oh, it's almost a tie. And it's raining cats and dogs,
it's very
right?
tight. Look at that. Yes. There you go. Whoa. And the dashboard, basically, it's picking up RabbitMQ messages from a message broker. And it's just showing that every time that somebody cast a vote there. Pretty simple application. How difficult it can be to build this.
So one note, keep your screen open on your phone, because the code that you see up here, you're going to need it later. So don't close the screen.
Yep. Perfect.
Okay, so it's almost a tie, but I think you're winning so far.
Dogs, just see.
Oh, wait.
Yeah, there you go.
Okay, I'll switch over as long as I'm, winning.
Yeah.
All right. So you mentioned this, but it's not a simple app.
It's not actually that simple, right? We are running this application on Google Cloud. I really love Google Cloud and how it works. It's pretty easy to create a cluster, but with a cluster on its own, you cannot do much. You can just run workloads, right? When you think about the Kubernetes API, it will let you run your workloads, pretty much what you can do there, maybe configure some networking stuff so you can actually interact with your workloads. But Kubernetes itself will give you that space. But then you need to add, another bunch of set of extensions like Set Manager. We're using Knative here for serving the traffic using HTTP traffic, right? Every time that you access the application, you are going through an HTTPS URL. And then for observability, something like Grafana and a bunch of other projects just to get this application going. And this is a simple application. Imagine if you start adding more and more services, right? It gets complicated.
Yeah.
So let's take a look into, how do you work with all this stuff?
Yeah, let's do that. First, maybe a few words about us.
Let's do it. So that's Mauricio Salatino. That's my name. I'm also known as Salaboy in the community, and I publish a book titled Platform Engineering on Kubernetes. I will be signing some copies at lunchtime. So if you're interested in getting a copy, just go into the checking area at around lunchtime. So I will be doing that. And I'm involved with a bunch of different open source projects like Knative, Dapr, the Captain project as well, and been working with the CNCF stuff for some time.
Yeah, and I'm Thomas. I work at Systematic. It's a software company in Denmark. I'm a software engineer, passionate about anything cloud native and Java. I combine these passions of mine and wrote a book also recently about this subject. Big supporter of open source technologies, contributing both in the cloud native ecosystem and in the Java space. Yeah. So recently we also took on a new initiative, right? So maybe we can...
That's correct. I think that, as you will notice, like this presentation is pretty much like developer focused. We wanted to figure out what are like the main pains for development teams to work with these tools, with all the cloud native ecosystem. So we started working at the CNCF inside the Tag App Delivery, which is a group inside CNCF, to bring developers closest to all the CNCF tools. This is an open group, right, like that you can join if you're interested in these topics, like developers and how to make developers more efficient, using which tools and which practices around them. So again, it's a CNCF working group that we are working with Thomas and some other folks from the cloud native community. And we try to help platform engineering teams also to understand a little bit more about developer practices and what do they do, the tools that they use, and the processes that they have in place. So if you're interested in that, please go to that URL. Join us. I think that we will try to do an conference on this topic too. So if you're interested, check it out.
Yeah. So speaking of developers, let's try to unlock some of these platform experiences with the focus on having these open interfaces, so that we can accommodate and be flexible enough to fulfill different requirements across different projects. And we start with the onboarding process. So as I said, a new development team, or whenever we have a new application idea, how do we start up a new project? There are multiple ways of doing that. A popular way is defining some kind of developer portal inside your organization. For example, using Backstage, we might have some golden path already coded for us. For example, if you want to build a Java application and use Dapr APIs on Kubernetes, then we might have a template for that. And that template embeds already all the best practices to build that type of application. And then,
let me ask, how many people are using Backstage already? Like we have some Backstage users, okay, a couple of Backstage users. Yeah, perfect, that's good.
Yeah, and then once we establish this template, we also have to think about how we're going to work locally, how to establish a local development workflow. For example, at some point we have to build an image, and we have the Cloud Native Build Packs project, which is really great. It's a polyglot tool, so no matter what language or framework you're using, with one simple command, you can obtain a production-ready container image. So you don't have to write a Docker file. You don't have to spend time thinking about how to make it secure, how to make it performant, because all that knowledge, all that information is actually provided out of the box by one of the build packs implementation. So that's a really great tool to optimize the developer experience, because we don't have to deal with Docker files anymore. And on top of that, we can use something like test containers. Test containers is another polyglot tool. You can use it across different languages to run your dependencies locally. So instead of depending on or mocking your databases or external services, you can run the real thing as lightweight containers as part of your application lifecycle. We have Knative functions that can also help streamline this process, so it can bootstrap a new project, even using build packs to containerize your application, and using Knative Serving to deploy it on Kubernetes, so taking care of the whole end-to-end experience. And if we look at the pipelines as well, we might consider something like Dagger to implement pipelines using our favorite programming language and codify everything in a nice way as well. Yep. So let's have a look at a simple demo here. So I have Backstage open here. This is the developer portal. I can find a lot of different information about my organizations, all my projects. And in particular, there is the section where I can create a new application, a new component based on some template. For example, here I can choose to build a new AI application, because, of course, there needs to be some AI, right? So I can build a new docs assistant, so we can upload some documents and ask questions about documents, and some description, because I'm really, really creative. I'll pick my theme. I want to create this new application on my GitHub repository. So I can provide that information. This is a Java application. I can specify the namespace for my application. This is a docs assistant, and will be under Thomas Vitale. It's an AI application, so now I have everything codified to build integrations with a model. For example, Mistral, OpenAI, I can use Ollama, which runs on premises and locally. So I like it. A vector store, Postgres is just amazing, so I'm going to use Postgres and choose how I want to establish a workflow. Let's use GitHub Actions. and that's it. Now I can create the project. So I have already opened it locally. So what happens is that I can work on my application as a developer, and I don't have to worry about how to establish all these integrations, like how do I get access to a model, how do I get access to the database, because when I run the application, I'm using test containers under the hood. What happens is that I get both an Ollama service and a PostgreSQL service out of the box.
Yeah.
So you can see the configuration here. There's an Ollama container, a Postgres container with pgvector that acts as a vector database. So now I can implement the logic of my application, and I can even ask a question. So I'm a musician, so this document assistant application will answer questions about different bands. Let's see, who plays the piano in this band of a document I just uploaded? Let's find out. I have this Ollama service. This is an on-premise model provider, so you can run all your favorite models. And of course, based on the internet connection now, it might take a while.
Interesting. Kind of important to mention here that the demo that Thomas is running is just running on his laptop. It's not running on a Kubernetes cluster, but we want to make sure that we build these applications in a way that we can just build it locally and then just push it to a live cluster with all the services installed in there, and it will run in the same way. So we want to make sure that we enable a developer experience that runs on their laptop with the right abstractions. Sometimes Kubernetes is part of those abstractions. Sometimes they don't want to learn about it. So we just need to make sure that they can run the same services in the same way.
Yes. Now I'm rerunning the application. And what happens is that I get, again, these integrations already part of the project. I'm using Java, but you can use it with C#. You can use it with Go, with Python, with Rust. So it's available across different projects. And once I'm done building my application, of course, I can commit my changes, do a git push, and that's probably it for the onboarding part.
Yeah, sounds good. So yeah.
So one last thing I'd like to mention is that we don't necessarily need Kubernetes or force development teams to use Kubernetes. In this case, I don't have any Kubernetes cluster working locally, because across different stacks, there might be already a good developer experience provided by the framework you're using. Maybe with Flask in Python, I can just say Flask run. Or now I'm using Spring Boot with Java, I can say boot run. And then under the hood, I get all the integrations I need via test containers or something like Microx. So I don't need to make the developer experience locally too much complicated. But that's only about one application, right? So what if we go distributed?
We would switch. Yeah, so the idea here is that, again, when you have one application, when you're dealing with a single application stack, you might be able to have things under control, but when you're building distributed systems, you are dealing with more things than just your application, right? Should be OK? Yeah, that's what you're saying. OK.
Yes. Let's do some screen mirroring.
Screen mirroring, display settings.
Yeah, when we have distributed systems, we have to consider also how to integrate with other applications, because using something like test containers, we can have easy integration with something like databases or some other off-the-shelf services. But when we start building a system like what we showed earlier with multiple applications, we have a few challenges.
It gets more complicated, right? So if your application is dealing with multiple services, what you will notice is that sometimes you cannot run all the services locally in your laptop. And sometimes you're using, for example, managed cloud services like the database or like an S3 bucket that you cannot run locally. So you will need a way to start separating your applications from the environment where they are running. And usually the way that we do that, like when you are like developing applications or architecting applications, is just to add an abstraction layer. And I really like the opening keynote where we went through like the concepts around like containers, Kubernetes, the abstractions that these things provide, because I believe that Kubernetes gives us a really, really nice abstractions to run our workloads, right? With the Kubernetes APIs and with the Kubernetes resources model, what we can do is we can define how we run these applications. But what we cannot do with those abstractions is to basically enable our applications to interact with their environment as soon as they are running. We can package applications, we can run them as containers, but these containers actually they don't have any visibility about the environment that they are running with. And if we add the right abstractions there for the environment, what we can do is we can enable every container written in every different language to interact with the things that are available in the environment in a unified way. So if we provide some unified APIs that these applications can use, no matter the language that they are being written in, we can enable these applications to perform different operations across different application infrastructure components. And that's why I want to talk a little bit about the Dapr project that I'm working on today. Dapr stands for Distributed Application Runtime, and basically what it does, it provides you these unified APIs for containers or any kind of applications to interact with infrastructure, making the applications like agnostic of the environment where they are running. And when I say APIs, if you go to the Dapr website, what you will see is that these APIs are most of the time just related to things that developers will do, like most of the day, right? It's not mirroring for some reason, so I think that I can do that, which is interesting. I don't know how we will type there. But basically, what it means for a Kubernetes user is that you're going to basically, in your cluster, you are going to install Dapr, which is basically a Kubernetes extension. And then you will basically have a way to say, my application is interested in consuming the Dapr APIs that are provided. This API will let you do things that applications will usually do, like store a state, retrieve a state from a persistent storage, send or publish messages and consume messages, read secrets, read configurations, interact with other services using some service discovery and stuff like that. And the main concept that I wanted to touch on this presentation, because we don't have too much time, is the idea of components in Dapr. So in my cluster, where we're running this demo application that we used, we have 3 components defined. There you go. So I'm typing there. So let me see if I can make it bigger so you can see. Can you read that? Yeah, I would say that's OK. Get components. Components. Yeah. So we have 3 components here. And these are like the representation of the components that I show in the diagram, right? So we have a Redis database, we have a PostgreSQL database, and we have a message broker. In this case, we are using RabbitMQ. So these 3 different components, the only thing that they do is they basically give you describe component. They give you a way of configuring how the Dapr APIs are configured to a specific instance of a provider. So for example, the boat state store, the only thing that this resource describes here, let me see if I can see it here on the screen, is I think that this is the only important line here down the bottom. For some reason, yeah, let me see if I can drag this up. So the only thing that this is doing is basically saying, if you want to store data, you will store it in a Redis instance. And where is that Redis instance? You will see here the Redis host and the Redis password, right? Then you have some other parameters to configure the connection and all this stuff. But what this is doing is enabling this other thing that we will see in the both application source code, which is being able to do from your application call functionality via APIs without directly connecting to this Redis instance in this case, or adding a Redis client to your application. So I have the boat service here, who is written in Go. Again, you can do it in Java or in any other language of choice. Let me go here. So you see here, save state. So this line here, I will just make it a bit bigger. This is so odd. There you go. So you have there, Dapr client, save state. The only thing that this is doing, basically, is telling, like, my application wants to save state somewhere, and then you use the component configuration that I just showed to tell the application where it's going to save that. How Dapr works is basically using the sidecar model to inject, a component very close to your application that will actually perform the connection to this database in this case. You can do the same with RabbitMQ, as I mentioned before, and you can do this with other things, like, for example, managed services. So if we're running our application inside Google Cloud, what we can do is actually replace our Redis instance, our RabbitMQ instance, and our PostgreSQL instance for managed services in a cloud provider. Because we are using unified APIs, there is no need to change the application code. The only thing that we will need to change is the component configuration for the environment that we are running in. So our application now can run locally with some test containers integrations, as Thomas showed before. But then you can move this application to different cloud providers because they are relying on the same APIs no matter what. And because now we have APIs, that basically means that we have an abstraction layer where we can start building best practices. We can build in observability. We can build security in this abstraction, right? Some of the things that we are doing in the application, for example, the vote service is casting a vote, storing it in Redis, and then publishing a message. Because we are doing this behind APIs, what we can do is we can say, instead of doing that, what we can do is, like, we can generate a message every time that we store something in Redis. And we can do this transactionally, right? This is called, the outbox pattern, and it's a quite common pattern on distributed applications, where we just need to guarantee that whenever you store some data, you emit an event. And you can do this in Dapr because, again, you have like an abstraction layer where you can configure this functionality out of the box. And super interesting, you can do that across different technologies, right? Even if you're using managed services, Dapr will guarantee that these two things will happen, atomically, which is kind of interesting. And on top of this, you can start building more and more complex, constructs like workflows or durable executions, where you need to orchestrate a bunch of, different tasks together, and these tasks can be spread out in time, right? Like sometimes you need to wait some approval for someone, that maybe is on holidays, and you need to wait for that person to come back, approve something, and then just call another 10 services. All these patterns, if you go to the website, to the Dapr website, you will see, that as soon as you have the basic building blocks covered for managing state, for publishing events and consuming events, all these things can build on top. Now we will switch again, to Thomas' presentation, right? Let's do it. Thomas, your turn.
Yes. So we've been tackling some of these distributed systems challenges with Dapr. So let's get the screen back on where we left. So we left with the application. Yeah. So actually, we can see if it's working correctly. So now I get an answer. So what I'm doing is I can use test containers. It's an open source tool. I can run it locally on my container runtime. What I did here, since I'm running a lot of things on my laptop, was to transparently enable Test Containers Cloud, which is a way to transparently rely on a cloud resource in order to run those containers. So that's why it wasn't working, because I had some connection issues. But you can run it locally. It's designed for that. But for when you have special needs, maybe in your CI pipelines, when you want to use test containers for testing, or in this case, I'm running models, so I need GPU, then I can use the cloud service with dedicated infrastructure. All right, but I push my changes now. What happens next? So I can do it in different ways. Now, a common way of doing that, and probably not great from a developer experience point of view, is forcing developers to learn a lot of things about Kubernetes and maybe all the internals of your platform, Helm charts, or maybe even learning Istio and network policies. That's not good. Maybe a different approach is trying to shield, again, this concept of abstractions, shield developers from the complexity, from the implementation details of the platform, and expose something more friendly. Something so that developers only need to provide information that they know about. So I could use Crossplane to define a nice API. In this case, I called it a workload API. And there are only a few fields that the developer needs to provide: an image name, some meta information about the language and the framework, and what are the claims for services. So I want to integrate this application with two specific services. I can just name them. And then the implementation of this API will take care of the rest. So what I can do, for example, is using Knative Serving for serverless deployments of this application. In order to bind the application to other services, I can use the service binding API. Maybe I have the Dapr runtime, so I don't have to configure the application explicitly with the password and endpoint to call Dapr, but I can rely on service binding to do it automatically. So we are reversing the control there. It's not the developer that needs to configure the workload, but it's the platform that is application aware and provides what the application needs. And also some conventions in terms of memory, CPU configuration, probes, so all things that the platform will provide. And if we want to go above or beyond serverless deployments, like we work with some applications that are standard web applications, so we can just scale them using Knative Serving, even scaling from 0 and to 0. But if we have more event-driven applications, like we talked about workflows, we can integrate that with KEDA to achieve the same result, but based on events, something more function-aware. And again, we have Dapr for providing all these APIs to build these microservices, so APIs for different types of data services, configuration services, secret services, any kind of environment API you might need. And then we have the application deployed. So in this case, in the project, I only have that workload configuration. And as a developer, I didn't write that. It was part of the golden path that came out of Backstage. But then based on this information, the platform does all the rest. So in the case of the cats and dogs application, we can see that the application is fully up and running, and that under the hood, for example, we are using RabbitMQ. So even though we are talking with Dapr directly, actually under the hood is RabbitMQ doing all the messaging. We have Knative Serving that is supporting all the requests. Let's have a look at the scaling. So looks like you didn't overload the system, so we still have only one replica.
One replica, yeah, that's good.
Yes, and at the end we have the platform overall. That's the last challenge we would like to mention. Oh, it's still raining cats and dogs. That's fantastic. So for the platform, in this case, we use Carbel in order to packaging all the capabilities of the platform. So with as one single artifact, we have a portable, nicely portable platform. Based on that, we're using Flux for some GitOps workflows, and OpenTelemetry is the underlying APIs, of course, for observability across both applications and platform workloads.
Which makes it really nice is that if we want to recreate this environment in a different cloud provider, we can quickly do so, right? We just need to create a cluster somewhere. We are not automatically provisioning clusters right now. It's like that would be too much for this example. But if you want to replicate this example in a different cluster, it's pretty straightforward.
And we've done it ourselves. Like we are using different cloud providers, also local environments, and then we have a nice way to just replicate the environments everywhere.
Exactly. Yeah.
Yes.
So I think that we need to close it off. Yeah.
Yes. Let's go to the
I think
raffle.
That we can just do a raffle. So I have a book copy here, and let's see who is the lucky winner. First of all, we need to check cats or dogs. Cats or dogs? Are you going to? That's.
I'm so happy.
I think that you need to refresh that. That's
no. I'm not going to do that. No.
We have 77 votes. Thank you very much for voting.
No, that's okay. Let's say that now voting is stopped.
1. There you
so
go.
It's 54%.
We need to have a button to stop that.
I'll take a screenshot. Wait.
There you go.
Just to make it official.
That's official.
So
okay.
now cats won.
Cats won. So we can run basically here. What we are doing is just running a workflow.
Yes.
Drum rolls for the winner. And then let's see. Yes. So we have a winner there. I think.
So check the ID on.
Can you make that bigger?
Yes.
Yeah. There you go. So if you have that ID, let's see. Do we have the winner in the audience? Hey, there you go.
Awesome. Congratulations.
Congratulations. So there you go. So we have a winner. Awesome.
Yes.
And I will just go on.
Did the winner got the book?
Let's see it. Yeah, let's do it. The winner got the book. Yes, congratulations.
Yes.
Awesome. And I think that that's pretty much it. What we showed here is a bunch of different tools, a bunch of different projects. They all promote, in some way, open APIs that you can use to abstract concerns. We saw build packs. It abstracts how you create containers. We saw, well, Flux and Argo CD will abstract the way that you configure clusters. We saw Dapr. It provides APIs to abstract your application from its environment and from its, like, where it's running. It extends Kubernetes runtime with some APIs to do more things. So your teams, depending on which language they are using, they can implement the same behaviors without reinventing the wheel.
Yeah, and these are all different tools, so they don't necessarily help with your specific use case. So it's just good to know that we have all these options and then pick the right tool for the right job. And one more thing I'd like to say, we need to talk with developers and really validate the experiences. So if you're building platforms, make sure to reach out to developers because they're going to have really great inputs for you. And that's also why we started this working group in the CNCF to bring more the developer perspective into the whole platform discussion.
We are out of time, so if you have any questions, please feel free to grab us outside. Or
thanks for joining, and have a great rest of the conference.
Thank you, folks.